This video will cover a word problem, calculating Poisson probabilities, and using different calculators or StatCrunch. The problem in Math Excel reads, cars arrive at a certain restaurant's drive-thru at a rate of 0.2 cars per minute between the hours of 11 p.m. and 1 a.m. on Saturday evening. The restaurant begins an advertising blitz that touts its late-night service. After 1 week of advertising, the restaurant's officials count the number of cars, X, arriving at the restaurant's drive-thru between the hours of 12 midnight and 12:30 a.m. for 202 of its restaurants. The results are shown in the following table. Okay, the table shows us that their poll had 5 restaurants with only 1 car arriving for those 30 minutes of midnight until 12:30. 4 restaurants had 2 cars, 13 restaurants had 3 cars, and so on. And we can look in the middle here to notice 26, 28, 26, and 27 restaurants had anywhere from 5 to 8 cars arriving. To solve this problem, I need to know a mean. So we can remember that the mean is equal to lambda multiplied with time. And question A gives us the information that we need to proceed further. Construct a probability distribution for the random variable x, assuming it follows a Poisson process with lambda equaling 0.2 and t equaling 30. This is the probability distribution of x before the advertising. Remember that x equals 0 through 16, meaning 0 cars through 16 cars. The t is representing 30 minutes. That's the 12 midnight to 12:30 a.m. The mean is calculated as 0.2 multiplied with 30, which is 6. So our mean is 6. While we're at it, we'll calculate the standard deviation, the square root of 6. The square root of 6 is 2.4. Now to complete part A, if I want to know the probability of 0 cars arriving, I would have the probability of 0 equals the fraction 6 raised to the 0 power e to the negative 6 over 0 factorial. Now I'll show you how to type that in, or at least one way to type it in. And the decimal form is 0.00247,875. And we are to write our decimals out to 4 decimal places. So this is 0.0025. I'm going to type that into our different boxes here and make all those calculations. All the probabilities in the table can also be found with StatCrunch instead of doing the calculations by hand. If I go to Statistics, Calculators, Poisson, I can type in the mean of 6, and I can say that I want to exactly equal an x value of 0, and hit Compute. So you can see this x value of x equals 0 has a probability of 0.0025, which is exactly what I had in the table. Similarly, if I change this to an x value of 1, I have a probability of 0.0149. Now that I have the table filled in with all of the probabilities, I'm ready to move on to question B. I've actually done the work, but I want to show you how I did it. It says, compute the expected number of restaurants that will have 0 arrivals, 1 arrival, and so on. Right. I needed to remember that there were 202 restaurants. So I took each of these probabilities and I multiply it by the 202. So over here in Excel, there's 0 cars arriving and the probability, and then I multiply this probability with 202. So you can see up in the formula, I took the probability found in cell B1 and multiplied it with 202 restaurants. The comma 0 is to help us round this to a whole number. So 0 cars arriving will probably happen at 1 restaurant. 1 car arriving will probably happen at 3 restaurants. 2 cars at 9 restaurants. And this is the expected outcome if there was no advertising at all. Okay, so coming down, you can see in part B that I have the values from the right-hand column over in part B. 0 cars arriving at 1 restaurant, 1 car arriving at 3 restaurants. Moving on to part C, it says compare these results with the number of arrivals after advertising. Does it appear that advertising was effective? Why? And the first question is, what is the observed total number of arrivals? Well, I need to use my table of information. I'm going to copy this to a clipboard because I don't really want to open a different window in Excel. I'm going to hit Control-C, come over and paste it in Excel. All right, this is what was actually observed. There was 1 car arriving at 5 restaurants. So I now want to take 1 car arriving and multiply it with 5 restaurants, because that means 5 cars total were accounted for. Then I want to take 2 cars arriving and multiply that with 4 restaurants to give me a total of 8 cars. Now in Excel, I can copy those formulas and drag it down. So we can see that when 6 cars arrived at 28 restaurants, that creates 168 cars. If I total this far right-hand column, I find out that there were a total of 1,367 cars that arrived. And that's what I want to type into Math Excel. What is the observed total number of arrivals? 1,367. Before advertising, what is the expected total number of arrivals? Well, I want to come back over to this set of data that I had worked on earlier. Well, I similarly want to come over to Excel and look at the first set of data on our left, which had to do with the expected outcomes. We had 0 cars arriving at 1 restaurant. So we would want to take 0 cars and multiply it with 1 restaurant, which will be 0 cars. I also want to take 1 car arriving at 3 restaurants, which is 3 cars. I'm going to total those values. To find out that there were 1,197 expected arrivals. So the observed arrivals is definitely more than the expected, meaning that advertising was helpful.